problem number 8, sheet number 1, which is related to engineering scale. Engineering scale has two types, basically plane scale and diagonal scale. This problem is based on plane scale. So the length of Khandala tunnel on the Mumbai-Pune expressway is 330 meter. I'll show you one thing, like if this is a map and this is a Khandala tunnel. So this Khandala tunnel is on the Mumbai-Pune expressway. Actually it is 330 meter, but on the map it is shown with the length of 16.5 centimeter. So this data is given to you. So by using this data, you have to calculate RF. RF tends to representative fraction. Remember this for the full form as well as the definition. It might be asked in MCQ or in 1 mark question. So RF is representative fraction, and the definition is RF is the ratio between drawing length to the actual length of an object. So drawing length, in this case you can see what is a drawing length. 16.5 centimeter is a drawing length, and actual length of the map or the actual distance is 330 meter. So first of all you have to calculate RF, but in most of the cases RF is given to you, but if it is not given to you, this data is you have to find out from your problem, and you have to find out the drawing length and actual length by using that. So drawing length is 16.5 centimeter. You have to write down by using with units also, and actual length is 330 meter. So as ratio is nothing but unitless entity, so you have to convert all things in single units and eliminate each of them. So 16.5 into 10 mm divide by 330 into 1000 mm. So meter into mm and centimeter into mm. All the ratios must be written in form of this. Okay, so this is the style of the ratio representation. So we have to convert one of the things by using 1. So we are using this mathematical term 1 divided by 330 into 1000 divided by 16.5 into 10. So now you can calculate this thing by using calculator. If you calculate this if you eliminate these words, zeros, and calculate this by using calculator, you got this answer 1 by 2000, which is 1 tends to 2000. So this is the right way to represent any RF. So our RF is we found. Next one is you have to calculate LOS. LOS, that means length of scale. Length of scale. Now what is length of scale? You can see this is a scale. This is one type of scale. The length of this scale they are talking about. This scale is used to measure centimeter and millimeter up to 30 centimeter. You can measure these 2 units by using this scale. Okay, so what is the maximum length of this line? What is the maximum length of this scale you have to construct? So it is based on the units which you want to measure and the RF. So length of scale you have to calculate by using this equation, which is RF into maximum length. So here RF we have already calculated over here. So 1 upon 2000. Maximum length, you have to find out maximum length from the statement. So construct a scale to show meters and to measure up to 400 meters. Up to 400 meters, that means this is a maximum length you have to measure. So 1 by 2000 into maximum length is a 400 meter. Again you have to convert into millimeter. So 400 into 1000. If you calculate this like this, so it is 200 mm. So your length of scale is 200 mm. So by using this data you have to construct your scale. So now let's start with the this data. So this length is, first of all, construct a line with the length of 200 meter, which is 20 centimeter. So we have to construct a scale like this. So we can construct a scale using only single line, but most of the time we have that practice that the engineering scale or normal scale is a structure of rectangle. Okay, so we have to construct a rectangle over here for better visualization. So construct a rectangle. The dimension of this rectangle, or we can say the height of the rectangle, you can take anything according to the size of the scale. If the length, scale length is very short, like let's say 10 centimeter, then don't take more than 2 centimeter over here. I have choose 3 centimeter line. Okay, so for better visualization, you have to construct a rectangle with the 3 centimeter line and complete the rectangle. So this is look like a scale, a plastic scale which you use in school life. So this is the scale, but in this case we have choose some of the data of RF as well as LOS. So you have to mention that data in this direction like this. You have to extend these lines as the dimensions, and you have to write down length of scale is equal to 200 mm and RF is equal to 1 tends to 2000. Now this length is represent 400 meter. This length is represent 400 meter actually. So if you need to measure 400 meter, then this is the ideal stage of the scale. But if you need below that 400 meter, let's say 200 meter or even 220 meter, then you have to do some partitions. As an example, you can see this scale can be measured up to 30 centimeter, but if you want to measure 20 centimeter, then you have to mark these scales accordingly and you can get a 20 centimeter over here. So same way you have to divide this scale in such a way that you can measure below 400 meters. So we are going to divide this 20 into 4 equal parts, because this is ideally to measure 400 meters. So we can divide it into 4 equal parts. So 200 divided by 4, which is 5. So 5 centimeter each, and construct this kind of vertical lines to separate them. So 1, 2, 3 and 4. So one part represent 100 meters. So we have to mark some initial point. So this is my initial point 0. This is my 100, 200 and 300. What this means? This means this portion is 100 meter. Up to this it's a 200 meter. Up to this it's a 300 meter. So this is up to 300 meter you can measure. Now one more thing, whatever the dimension you are measuring, this dimension, this number is indicating meter. So you have to write down meters over here in capital letters. Okay, in this. Now you can if I ask you to measure 100 meter, then it is easy to measure like this. 200 meter is also easy, but if I ask you to 220 meter, then for that you can see in this scale all the partition of 1 centimeter is again divided into 10 equal parts to measure millimeter. So here also you have to divide this part into 10 equal parts, 10 equal parts and 10 equal parts. But no need to divide in each and every divisions. What we are going to do, we are just dividing first part into 10 equal parts to measure a smaller meters like a tens. So this 5 centimeter divided into 10 equal parts, which is 5 mm each. Draw vertical lines from them. In engineering scale also you have to draw it with a thin line, because it's look good. If you draw a dark lines, the whole structure will be look dirty like this. So this represent, this one part represent 10 meter. This is 20, 30. Now this from 0 to 30, it's a 30 meter. This is the 30 meter. So accordingly, and this is whole 100 meter. So one part is 100 meter and we have divided into 10 equal parts. So each part represent 10 meter. So again the unit is meter. So you have to write meter over here like this. So your scale is ready, which can be measured up to 400 meter and which is relevant to this example of RF, like 330 meter representing 16.5 centimeter. So if they ask to measure like 290 meters, show the length of the 290 meter on the expressway, so you have to measure the distance accordingly. So 290 meter, so 290, that means 200 and 90 from this side. So extend this line 200 and extend the line from 9, and this distance is your 290 meter. So this is your answer for this problem. So I'll add one more thing, like 100. If you want to measure 130 meter, then so this is your 100, extend this line 100, and 30 is from this side. So this is your measurement of 130 meter. So this is how you solve the problems of plane scale.